We are given the centers of two semicircles as O1 and O2. These three line segments are equal. Line segments AB and BC are perpendicular. Line segment QR is 1 unit. T is the tangent point of two semicircles. And we need to find the length of the line segment AB, which is the diameter of the larger semicircle. Let's start with naming the radius of the small semicircle as small r. Then these line segments will also be r units, and call the radius of the large semicircle as big R. So this part will also be r units. Now connect the center points of the semicircles with a line segment passing through the tangent point T. So this part will be a radius of the larger semicircle. And this part is the radius of the smaller semicircle. Now focus on this yellow right-angled triangle. We can apply Pythagorean Theorem to have a relationship between small r and big R. So big R squared plus 2 small r squared will be equal to the square of big R plus small r. If we take the squares and rearrange the terms, we will end up with this relationship 3 small r equals 2 big R. Now focus on this right-angled triangle. Notice that bottom side of the triangle is 3 small r and the left side is 2 big R. We showed earlier that 3 small r is equal to 2 big R. So this triangle is a right-angled isosceles triangle and its base angles should be 45 degrees each. After that, let's connect center of the large semicircle to point Q. Notice that this line segment is also the radius of the semicircle. Then we have this isosceles triangle. That means its base angles must be equal. And from here, we can see that this is a right-angled isosceles triangle. And its hypotenuse will be simply r root 2 units. Now connect the center of the small semicircle with point R. And focus on this triangle. Similarly, the other side will be r units. The other angle will be 45 degrees. And so the remaining angle will be 90 degrees. If we use Pythagorean Theorem, the hypotenuse will be small r times root 2. Now again focus on the large right-angled isosceles triangle. We know that the hypotenuse must be equal to root 2 times one of the legs. Let's use 2 big R for the leg length. And the hypotenuse will be the sum of these three terms. And instead of small r, we can write 2 big R over 3. Solving this will give us the value of r as 3 times root 2 over 2. Since we are asked the diameter of the large semicircle, that will be 2r, and our answer will be 3 times root 2 units. I'll see you on the next one.